And that's great. I mean, that was the goal, and why I wanted to release it initially, was just to facilitate raising the bar and making it easier for people to do things in an easy way, but also in a responsible way, in that it's doing what they need. A lot of times people, and it's a balance that developers have to try and meet. People want something, but then what they want and what they need aren't often the same. And so we have to try and figure out, well, how do I make those two things merge and make it effective, while still meeting their requirements, but also potentially giving them something they didn't even know that they should have considered. Whether that's an audit trail, or whether that's being able to access volume shadow copies, whatever it ends up being. A lot of times where I think people and companies get in trouble is that there's the people, this is what I think I want. And then they find a developer that knows how to code, and they're like, you could pay me and I'll do exactly what it says on that piece of paper. I don't really know what that means or why you would want to do that, but I can take a spec and turn it into code and a program, and I've met that requirement. So when you can have somebody that can step in from, I've been an investigator, I've been a forensic examiner, I've been a programmer. Well, now you start to merge those three kind of lanes together, and you get a much more thorough approach to what you're trying to do that meets those requirements, right? Yeah, there's an aspect of it. If somebody looked at a lot of my code, I'm sure a professional coder would be like, oh, I see some anti-patterns in there, and you probably should come up with a way to iterate through this. There's the classic computer scientist, this is what the theory looks like, but then there's this actually works, and this is performant, and it's easy for somebody to understand. That's also part of it. With multiple layers and all this, I'm going to have all this abstractions and different layers where things get passed through, and we'll do code injection up front with this dependency injection. Sure, that is all fantastic technological good stuff. But at the end of the day, if somebody looks at the code and has to testify or understand or is trying to learn, and they're like, it took me 4 hours to get to where I'm actually parsing bytes, that there's a trade-off there. And so, accuracy is first and foremost the thing that needs to be considered when it comes to forensics. Speed comes second. You could do things really, really quick, but if you're missing a lot of stuff, or if you're wrong, then what's the point? So get the data correct, then go back and optimize. And most of my stuff, really, whether it's KAPE or whether it's all the easy tools, as they're kind of known collectively as, those all started off as, one, me wanting to understand an artifact better, and two, thinking there's nothing out there right now that's doing what I need it to do in a way that I need it to happen. And so there might have been C or C++ libraries, or somebody else wrote this, some .NET thing, but it didn't do this other stuff. And so it was a matter of, I as much as I can, try to avoid rewriting things just because, so that they're equivalent. That thing's already over there. Why do I want to write a parallel thing that's essentially the same? So I don't necessarily ever port from one thing to another. I also try to not rely on other people's code when I'm building something. And by that, I mean, if I know that Mark has written a parser for fill in the blank, I'm going to write a parser in C# for this. Well, if I go look at your code and you've made assumptions or whatever, I don't necessarily want to make those unless I get down a road where it's like, I think I have all this right. Let me compare, see what else I missed, or I'm not parsing that out. Sure. And that goes back a long way. Really, KAPE is an iteration of triage in general that I don't saying that I was forced into it's probably not the right way to describe it, but it was out of necessity. So I've been into development and programming and managing computers and all that stuff since I've been, out of college, early 20s, whatever. And when I joined the FBI, I got put on a task force. And of course, one of the things that we need to do all the time is go through evidence, and we would get more and more evidence and it becomes inefficient. We have these tools that aren't doing what we need. And one of the people on the task force is like, hey, I heard you are good with computers. You know how to program. We need something that can help us go through pictures and videos faster. Okay. Well, let me see what I can do. And then look there. Now you can see all the thumbnails of the pictures. But wouldn't it be neat if, and then it was fill in the blank artifact, right? Oh, how about show me link files? Show me browser history, show me passwords that are saved, whatever. That just kept getting bolted on. So way back in the day, probably 2010, somewhere in there, I had written a tool called zsearch, which was kind of like grassroots, me in Salt Lake City, which is where I was with the FBI. And through my contacts with other agents and law enforcement that were doing crimes against children stuff, I'd say, hey, test this out for me. Let me know if this is a horrible idea or if this is useful. And so we started using it locally on the task force. We started using it locally at my field office. Agents in San Francisco started using it that I knew. And then I got it in front of a supervisor, and he's like, well, my guys are going to use it because that is a huge step forward in what we're able to do. So time goes forward. Bureaucracy does what bureaucracy does. Somebody finds out about zsearch, and it's a huge fiasco internally as far as like, who are you in Salt Lake City to be writing this tool? You're outside of your lane. And so that became a problem, right? Especially me as a newer agent. It's like, great, now I got people at headquarters and titles that I don't even want anything to do with. They're looking to cause me problems, whatever their intentions were, right? And some of them maybe we need to make sure we're doing this the right way because precedent and case law. I'm sure that might have been maybe part of it, somebody somewhere, but a lot of it was just, you're stepping into my kingdom, and I don't like that. And so during the course of that, one of the supervisor that I had initially started to run this through, he was pretty well connected and could facilitate getting stuff done in different places. And so the software went to get tested. And initially, that was kind of what happened after. Initially, one of the groups that tested it really didn't do anything. I think more or less the directive was find something bad that we can say and we can just shut this down, write up a report and make it go away. And so they wrote like a 2-page summary whose essential conclusion was zsearch is malware because Norton antivirus flagged one of the files in it when I ran it. That was basically the premise of their conclusion, which was a Nearsoft utility that pulled passwords, like saved passwords for email or chat clients and stuff like that. So clearly not malicious, but now this is official government record, right? It's in the system. And so I wrote a 42-page response, basically just reverse engineering the code that they were worried about and just showing that all their concerns were not founded. But now that was official record. So now you have 2 opposing pieces of paper in the system, and it was now the position of FBI lawyers. Well, anytime this software is used, those statements are going to have to be given over to the defense. And now their solution was just rename it. And so I changed it from zsearch to OSTriage, and everything was now just fine. It went through the process. This is where that supervisor came in. It went through, all the various back channels of testing and validation. And that's a whole nother story in and of itself. but it finally was approved, and now it's a worldwide global law enforcement related tool. So literally tens and thousands of users using it all over the place. I mean, it made thousands and thousands of cases. And so that lineage, that was OSTriage version 1. Then I wrote version 2. And in version 2, I basically made all the functionality modular. Whereas OSTriage 1, it was a single monolithic app. So if you're like, Eric, I have a great idea, can you make it do this? And I'm like, maybe for the next release, because I have to like do all this stuff and then give you a whole new huge executable. So in version 2, I made all of the features externally driven. So they're all DLLs. And if you write to a certain interface, right, a certain programming interface, and your DLL is an OSTriage plugin, it will do whatever you've programmed it to do. And so now you can add more to it. You could strip it down. It's much more modular. So that was OSTriage. But OSTriage was more for the frontline investigator. It wasn't meant for a forensic examiner. Somebody that knew what they want. You could have a meaningful discussion about, let's distinguish between prefetch and the USN journal. Whatever forensic type artifacts that you want, OSTriage is not necessarily the tool for that. It takes a lot of different things and displays them in a consistent way for a less technical investigator to be able to make sense of and move the ball forward in their case. Now, when I left the Bureau in 2015, late 2015, and I went over to Kroll, at the time, somebody was working on, literally, it was a batch file, .bat kind of a thing. And it was, I need to add fill in the blank artifact. Okay. And they go in there and they add another if else, or, a switch statement or whatever the thing was at the time. And, everybody knows the problems with that, where you're just stringing together disparate output and it's brittle and I can't extend it and say, I only want to do this, but not that. So my boss at the time, I'm like, hey, I want to take that and kind of turn this into an actual program / framework. And that's really where it started. It was to basically move away from doing everything in a command shell to being able to do things more forensically. And so that's where KAPE came out. The idea started. I don't remember. I think they probably did call it that even from the very beginning of that process. But the goal was initially just collection, right? And so strip away the need to even write code anymore. You don't even need to write any C# or anything, and make all of the collection definitions externally driven. And I just use YAML because it seemed the simplest at the time versus making somebody do JSON and escape backslashes and quotes. Most people are not going to tolerate that. So YAML made it simple to do key value pairs, define nesting, all that kind of stuff. And that's where it started. So I just had a framework. KAPE in and of itself, it really doesn't know how to do anything. If I just gave you the executable, you'd be disappointed because it doesn't know how to collect anything. It gets all of its functionality based on those targets. And so the targets are what we define to have it collect an MFT or link files or jump lists. And we can do regex and it can do recursive searching. And then from there, just like I had described before, but it would be great if now I need to collect this. Now, because it was all external, now anybody could write targets all day, do a GitHub fork, do a modification, and then do a push request or a pull request. And you have the new targets and modules. Now, well, the targets anyway, modules are a separate thing. So it was very easy then for me to, like, other people can start defining file specs and types, and this log is here and that log is there. Like, I don't care about that. So I don't need to feel like somebody's coming to me and saying, can you make me a target that collects these Wizzo logs because they're really important to me? No one else, it's such a niche thing, but now I don't need to, you don't need to involve me. You are in control of what you collect, how you collect it, what you call it, everything, which is great for you. And it's great for me. I don't have to deal with that. Nor do you have to wait for me to go, I don't really feel like that's a good idea, right? So it takes me out of the equation, and it's kind of a mutual thing. And then from there it was, okay, well, I'm reading a file system. Now, what about lock files? It's a huge problem when you do live response on a system and registry hives are in use or event logs are in use, or I need the MFT. So now I have to have a way to do raw disk reads. So you figure that out. Now doesn't matter if the file's in use or not, I can do a raw disk read the underlying clusters, and I have the data. Now, meanwhile, we're still calculating a SHA-1 hash value of the source and the destination as we're copying things out, and we're deduplicating. So you're not going to collect the same file more than once. You could turn that off, but I don't know why you'd want to. And then it was, well, this is great, right? You're letting me dump this out to a folder where I'm starting, but now I need to have all those files that I've collected in a container. Okay, well, I can zip them up. Okay, that's cool. Zip file. Can you put it into a VHDX? I don't know. Maybe. Yeah. Okay. Now I can do that. So people just have said I needed to do this. I wanted to go to S3. I want to be able to shove my collection out to Azure. I want to use a pre-signed URL, whatever the mechanism is. And so I've just added those things slowly over time, up to and including KAPE in and of itself has a built-in SFTP server. So you could use KAPE to start an SFTP server that's temporary. It will show you all the configuration switches when it starts. You take those switches into another instance of KAPE, collect through the enterprise, and when you're done, you just shut down that temporary copy of SFTP. So you don't have to like provision some server that's running on a Linux box and it's on the internet and it's available and we got to, now somebody brute force that. It's all temporary. So over the course of time, either myself or other people have, hey, we should make it do this, or have you thought about that? Now, at some point in there, I thought, because of the way this batch file was working, the collection's only half of the problem. Because and I don't know if it's easier or harder than the other half, but it's only half the equation. The other half is I need to get the data in a meaningful format from an MFT or a link file or a jump list or fill in your favorite artifact to analytical work product. So how can I go about automating not only the collection, but the execution of tools against the data you've just collected? And that's where the other half comes in. That's modules. Modules run command line tools. So I want to say we have like close to 400. So pretty much any command line tool that you could imagine, we have a module for, and you could run against either a live response, you could dump memory, you could run the tools that are going to capture a BitLocker encryption key, extract out the recovery key for you. You can run B strings, you could check the registry, you can parse out link files, anything that you could run programmatically just by manually going into a command line and doing stuff. We could run those command line tools in an automated fashion during the course of collection, right? Collect, process, upload, just upload my work product. What if I'm threat hunting and I don't want to backhaul a bunch of data? Well, just run those modules or collect locally, and every 15 minutes, upload a CSV for your favorite set of artifacts. And so from there, it kind of grew into this, what I like to describe as a processing tool chain, where I can collect and then extract my work product. But it's any of those things. If you have pre-collected E01 or somebody's like, hey, here's a bunch of link files, what can you tell me? Well, I could run LECMD manually, or I can just point KAPE to where those link files are, and I don't have to type out any of those command line arguments for LECMD. So everything is managed for you, and KAPE on the fly, before it executes stuff, will flip variables around and give the appropriate paths to where the files are and where you want me to save the data. So it's all transparent. So once you set up a module, you never have to type another command line again. Now, KAPE in and of itself is a command line tool, but there's a graphical wrapper called GKAPE that literally is a GUI, and you just click, 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 type in a box, and it builds you a command line at the bottom, and you just launch it. And then it, of course, spawns the executable, the command line version, does its thing, and you've got everything done pretty much in just a few seconds. So it depends on what you're doing, but 3 seconds to maybe 6 minutes for a typical collection is probably the average. And when you start comparing that to, well, it takes 4 hours to image a 1 terabyte hard drive, and then I've got to verify it. So that's 8 hours before I can even tell you, does this file exist? Has this thing been opened? Is there a jump list that points to the plans to the Death Star has been viewed on this computer? I can figure that out. I could do 30 of those types of questions before the first E01's even created. If we start thinking the way we need to think with the size of the drives and the way this problem just keeps to expanding, if we start to do those triage collections, because really, I don't care who's doing your exam, they're probably not looking at more than 1% to 2% of the data on that hard drive anyway when they give you back your report. So what am I waiting around for the other 98% that I'm just going to have to ignore and wait to be passed on by to start getting answers? There's a couple good questions in there. The what is the current state? How are people typically doing this? It's going to vary from, I'm only going to make an E01 first, and then I'm going to run it through this giant monolithic forensic program that's also going to take 42 hours to generate this before I can tell you anything. Like, even if I start right now and I do it as fast as possible, it's going to take me 40 hours, right? That's the kind of the traditional approach, or the, if you've heard this term thrown around the industry, this whole concept of Nintendo forensics, where people don't really want to know what's going on. They just want to say, find evidence, and it says, boop, here it is. No, well, how did that get there? I don't know. I just clicked on the email tab. What does that mean when it says this was open? Where did that come from? I don't know. I don't know what a link file is. It's just saying that this document was open. So that tends to be more the law enforcement side of things, at least historically. That's the way. And not that law enforcement's ever going to get away from making full disk images. A lot of places, if you're doing anything that's going to end up with criminal charges or otherwise, there's nothing wrong with making an E01. I'm not saying the industry should just forgo full disk images. No, but we definitely need to think about how we go about that classic process and refining it to make it better. Now, on the way other side of it, the people that are more used to doing threat hunting, well, that's all they do all day. They go out and they say, well, what is prefetch telling me? I want to know about what's running on my endpoints 10 times a day if I'm not monitoring them live, right? If you're doing any kind of incident response in anything of a significant organization, you are not dumping memory and making E01s every single time across thousands of machines before you could say, well, is anything weird going on? So a lot of times IR people are a lot more comfortable with the concept of live response and triage. And, I'm just going to take what I need. Sometimes, oh man, what do you mean you're not going to take a full disk image, or you're doing something on a system that isn't using a write blocker? That's going to cause a serious problem. It's not. It never did, right? And people need to just get comfortable with the fact that change is going to happen, whether it's you doing it or not. You're on a running system. And because of that, we need to do whatever we need to do, because we have so many more systems and so much more data. It's not only the number of systems, it's the size of the hard drives. It's going to continually erode our ability to make meaningful progress through these data sets if we don't have a way to focus in on what we want, at least initially, right? You don't need a terabyte of data to figure out the basic questions of what files have been opened. Does this file exist? Tell me about if this piece of software ran. That's very, very small subset of data. So if you start off on that kind of progression where we only image or we never image, the right answer, like most things, is usually somewhere in the middle. And that's going to slide around a little bit depending on what you're doing. But why not facilitate the ability to get these quick wins, to go in, grab what you need. And then if you need, there's nothing wrong with saying, oh, this machine, this looks bad. I could see the fact that this malware's on there, or we pulled the registry hive and I can see the C2 channel. Now I'm going to go back and I'm going to do a more extensive collection, maybe dump memory, maybe take a disk image. So one thing can lead to another, but why do we want to start there? We have to be a little bit more flexible when we're starting to do that. So I can't remember the second half of the question now. it doesn't really matter if you collect first and then KAPE it, or that you KAPE it live, right? That works. KAPE doesn't care, right? So let's just say that you have previously existing full disk images and you're like, this sounds like a really great process. How could I extract that? We can do that too, right? KAPE doesn't care if it's a running system or if it's dead box. So if you take an existing E01 and mount it with Arsenal Image Mounter, that file system is now available to you in Windows. Let's say it gets my example, it'll be like the H drive. So now I can just point KAPE at H, and KAPE is going to treat that just like it's doing any other disk, the C drive, the D drive, or whatever. Now, there's less to be concerned about with locked files, but things like the USN journal or the MFT, those are still special files because the file system is mounted and it's active. So that comes into play as well. And then on the other side, if you're just doing a bunch of live response, okay, well, I'm not ever really collecting anything except for the artifacts that I need to answer the questions. So I don't really have this full disk image concept that I have to mount. Now in the middle, if you have a dead box write blocked hard drive and you're getting ready to make a forensic image, right before you click make me an E01 in whatever your tool is, why not point KAPE at that mounted write blocked disk image, or disk rather, it's not an image, the disk. And within just a few minutes, you are going to have that 1% to 2% of your data. Now you start your full disk image, and if it takes 4 hours, who cares? Guess what you get to do for the next 4 hours? Answer every single possible question that there's going to be to know about that. And it's not like everything that you do while your E01 is being imaged or created, everything that you do is going to be directly transferable into whatever your system of record is, right? I would much rather personally have the individual artifacts, prefetch, link files, shell bags, registry, file system, USN journal, all those things extracted out in their complete and full detail, the most detail that we can get, because easy tools are purpose built per artifact to maximally extract out everything that we know about. Well, that is going to give you a level of visibility that you're not necessarily going to get when you have a tool that does a lot of things in a lesser amount of detail. So you're only going to benefit by using this type of a process. And you're like, oh yeah, there's that picture, there's that PDF, there's that executable that we're interested in. Well, it tells you the path. You can go find that in any other tool that you want. Bookmark it, add it to a report, send it upstream, whatever that looks like. So nothing breaks here. It really is just an improvement regardless of what your existing process is. Now, the current version of KAPE is dependent on .NET 4 being around, which is pretty low these days unless you have like a significantly neglected machine that's just never been updated or nothing's been on it. Maybe you'll have a problem, or like we still get people like, hey, I need this to run on Windows 2000. Maybe not, right? Now, the next version, I'm going to update it to be .NET 8. And it's also going to be completely self-contained. So there is no runtime dependency. So if you're familiar with Go or anything like that, where you could build a static executable, for lack of a better description, that's essentially what it is. Now, really, the runtime just gets packaged with it and extracts the memory. But the end result will be single executable on that system. It has everything that it needs to do its job. There won't be any, you don't have .NET. I'd love to move to .NET 6, but now we're in the same problem I was 12 years ago when .NET 4 wasn't everywhere, right? .NET 4 comes with Windows 10, Windows 11. It's going to work out of the box. So thoughts always kind of, well, how can I make this easier? How could I just have somebody drop this in on a system and it's just going to work? Those things are progressing. Not anything like, oh, amazing new capabilities. Now we'll gain potential efficiencies with the way .NET is improved. A lot faster I/O, faster file system traversal, stuff like that. But no, like, here's 80% new features, nothing like that. It's more about improvements to the existing architecture than like anything brand new. Really not, it's pretty stable right now. So it's really just trying to make it work faster and easier for people at this point. Yeah, that close. Yeah. So targets collect things. Now, you mentioned memory in there. Memory would not be something that we can just go get from a file system. Of course, we would need to run a program to dump memory. So that would fall on the other side. Modules run programs, targets collect things. So we would define a target, for example, for registry hives. That might include ntuser.dat and the transaction logs. That might be userclass.dat. That might be the SAM hive, system hive, software hive. But we keep the target definitions very specific and focused. You could make a target that collects 82 different things, right? But what happens if you only want 12 things one time? If you do it in a way that where you build a single monolithic target, you're forcing yourself to always collect everything. I don't need to always collect everything. Maybe I only need one thing. If you ask me, does this file exist in the C drive, in the C:\temp folder, I only really need the MFT. So what do I need the other 81 artifacts for? So when we create targets, we have ones literally just for the MFT, just for the USN journal, just for $SDS, whatever. And then we roll those up into a compound target called file system. And then file system would reference each of the individual targets, and KAPE it understands that, oh, that's another target. I'll just expand that definition. So you can think about like web browsers. If I gave you an E01 and I said, before you even look at this, I need you to extract out the appropriate browser history for me. How are you going to have any idea whether it's Chrome, Firefox, Internet Explorer, Edge, whatever? KAPE has a target called web browsers. I don't care what it is. Go find all possible web browsers that you know how to collect and then extract them out. And so targets collect files based on file specifications, star.pf, star.docx, whatever. And then targets via KAPE can also go into volume shadow copies looking for those same things. So we wouldn't necessarily say, I want you to go collect a volume shadow copy. It would be, go get me files from it that are different from the active file system. That's where the diffing comes into play. If I process the C drive or any mounted volume and I get 100 files that I found, and then I look through volume shadow copies and those same 100 files are there, well, if they're exactly the same from a SHA-1 perspective, I'm not going to extract them out because you already have that file. So I'm going to diff out and only extract out what you don't already have. And maybe we get another 26% from 3 volume shadow copies. You get those and it will tell you that it came from with each of those shadow copies. But you also get in your audit trail, I skipped this file from this volume shadow copy because its SHA is this, and we already have that. So in reality, you do have a copy of every single file, because if you look in your skip log and it says SHA 1, 2, 3, 4, 5, and then you look in your copy log, you find the file with that same SHA. That's the same file, except it's in a different path, right? So I almost treat it conceptually like a hard link. I've given it to you once. The relationship is there for all those things that we deduplicated, but I just saved you all that disk space and compression time and transfer time because I didn't collect those things in duplicate. So yeah, coming back to your questions, targets collect things, modules run programs. Those are the kind of the 2 pillars of the functionality. Sure. Yeah, no problem. So this is my KAPE. This is what it comes with. Now, the KAPE.exe, that's your main program. And then GKAPE is your graphical wrapper. Obviously, that one is significantly bigger than the actual tool that's doing the heavy lifting. So I have an E01 that I've mounted to the H drive, which is what I'll do all these targets against, the collections against. But you can absolutely do this against your C drive, a D drive, whatever. It obviously requires administrative rights when we're doing raw disk reads and all that kind of stuff. Now, notice also I have targets and modules there. So if I just go into targets, you can see that we've got them broken down by type. So for example, if I go into Windows, you can see that we have all kinds of individual targets that define each of the things that we might want. So here's what I was talking about: $J, $log file, $MFT. Now those if I go up a level and then I go into compound, notice that we have a target called file system.tkape. Well, that file system one is referencing all those individual ones, right? And so if I actually want to do a collection on that, it's very simple. Kape.exe is your main starting point there. Now, I've done some previous ones here, but I'll just type everything out. T-source is H. That's where's my stuff. Think of T-source like where's my stuff. Target is, well, what stuff do you want? Now here, if I said $J, now you have to be careful with PowerShell because in PowerShell, a dollar means variable. So if I just put $J and I didn't have those single quotes around it, PowerShell would be like, yeah, that doesn't exist. And you'd be like, what are you talking about? It's right there. So escape it with single quotes if you need to. And then T-dest, well, that's where do I want to put the stuff that I want to collect? So temp, T-out, whatever. Now from there, that's really all we need to do.
I'm sorry, I'm looking. You said $J is right there. What, when you were saying $J is right there, what do you mean?
Like for example, when I came up here, I said, there's the $J file.
Okay.
Like I know that target exists. I know that $boot's there, but when I type $MFT and I don't put quotes, PowerShell is going to go, oh, there's a variable called $J. Let me expand that.
Okay.
And then it's going to be like, that doesn't exist because there is no variable named $J.
And is $J one of your compound
$J is an individual thing for the USN journal.
Okay.
Yeah, file system. And the reason I'm doing this is to show you, basically, I want to collect one thing, and then I'm going to expand it. The next one I do is going to be the file system. And you'll see how it collects not only $J, but the MFT and some other things as well. Okay. So this is all I need. Now, if I hit enter here, it's going off and doing its thing. It's already done. So that took an entire 1.4 seconds to go in, find $J. You could see that it was locked, right? Because it's a special file. And so it put it into the deferred queue and it copied it out, it hashed it out, and all that detail is now preserved. So if we compare that to me going up here, and just to illustrate what I was talking about, see, it's like, well, you didn't give me a target. There's nothing specified for target because $J is empty. But if I change that now to file system, watch what we get. It's going to look very similar to the first time, but see all the files that it got? It got $J is in there, but yes, it also found MFT, log file, USN journal, the SDS, which is all your directory index, your security information, $boot, and so on. Now that took 5.6 seconds, which is still, yeah, I'll take that. Volume shadow copies becomes as easy as adding a VSS switch. And now when I run this, notice that it found 2 volume shadow copies. It's iterating through them. Look at how many more files it found. You can see references to VSS 3 and 4 in there, but I'm actively copying out individual different things from each of those. So there it took me 14 seconds to do something like that. And I could just as easily have gone back to this previous example and it would work the same, except I'm going to get less. So that illustrates this concept of keep your targets narrow and focused. I would certainly recommend that people come up with a good compound target called, company name default, FBI default, Kroll default. That way, every single time you run it, you get the same things and you don't have to sit there and string together, okay, I need prefetch in the USN journal, and then I'm going to do the link files. I don't want to sit there on the command line and start stringing these things together with a bunch of different options, because what happens if I make a mistake like that and I'm off by one or I mistype something? And so if we go back to targets and then compound, things like basic collection, sans triage, or KAPE triage, right? These are ones that we kind of, not all of these, but like, for example, this is one that we curate and we'll keep it updated. So if I go up here and do this again, all I have to do is that. We'll turn off shadows just to save us some time. But now it's going to go get me 17 different things. Whatever we've defined as this is the most important stuff, from registry to event logs to log files. There it found 1,200 files, and it's beginning to copy. Probably difficult to see, but up here in the title bar, you can see the percentage. So it's 90%, it's done. Now it's going through and it's doing the deferred. So these are the things that are in use. There, 24 seconds, and I've just forensically acquired everything that I need to do just about every case you can imagine. Dumping all that stuff, we could do the same one, into a container, VHDX, and we'll just call this, case 42, whatever. It's going to do the exact same thing. The collection does not change. But when it gets to the end of the acquisition, so we're about 50%. When it gets to the end of the acquisition, watch what it does. It's going to actually figure out how many bytes it copied, create a dynamically sized VHDX, copy everything in it, compress it, and now I have my evidence sitting in a zip file that is 334K, right? Compared to 164 meg. So whatever we get, we shrink. I could exfil that super easy, and off you go. Now, another thing that you might like, well, what if I have to do this on 280 different machines? Do I actually have to sit there and write out the results to different directories and come in here and say TOUT1, TOUT2? No, you can do things like %M or %D and timestamp things based on the machine name and everything else, and it will actually record. It will dynamically reflect those. So you can come up with one command line that is going to give you everything that you want across your entire enterprise, and you don't have to change the command line, which makes things a lot easier to do. So this one, almost done. And then it should show us there. You can see it right there. See how it figured out that my machine name is EZ-W? Well, that's the output. Now, there's also one for, if I just run KAPE here, there's other ones, but I think we show a couple here. Timestamp, system drive letter, machine name. So think about if you wanted to, on a reoccurring basis via a scheduled task, every 15 minutes, I want to capture the top 5 forensic artifacts across my most critical servers in my environment. So I could set up, let's just say it was KAPE triage. I could do something like machine name D. And now every time I run this, those results are going to be snapshotted into by a machine name, then the date timestamp. It will show up. Now, I don't want to sit there and wait for that again, not that it takes too long, but just so that we can see what it does. So there, it's going to figure out there. See how it timestamped it? So now it's this and then this. So ending in 5253. If I repeat it again, of course, it's not the same time. We get a different folder. So now, how long can I save 2.6 meg of my most critical data in my environment? Probably a heck of a lot longer than dumping memory and worrying about it. Or, man, we figured out we got compromised 3 months ago. None of my stuff goes back that far. I don't have logs. They only go back 3 weeks. Except we've been using KAPE to systematically do triage collection and put them on a file server somewhere. We can go back every 15 minutes for 6 months. It just makes life a lot easier. Now, not to say that you're going to do that across 10,000 machines, but even if you did, that's not a whole lot of space for how much you're going to be able to show down the line with things like that. Just bringing up the other, or some of the other things here. Those are the main ones. I'll do a module here in a second, but targets and then modules, you can simulate. I don't actually want to copy. I just want you to say like a what if, and then you have all your transfer stuff and so on. So if I wanted to get rid of that, I want to run PECMD, which is a prefetch parser against that collected data. So I could do something like mdest, C:\temp mout, mdest, tdest, where's my stuff I want to copy? Well, mdest is where I want my module output, right? So then I have to say what module I want, just like a target. So we'll say PECMD. That should be all I need. So now watch when I run this, it's going to run it. There it did. It just ran the command line for me. I didn't have to type that out, right? That is defined right here. This is what's actually in the module definition. And so percent something percent, those are variables that get dynamically flip-flopped at runtime. I have my CSV now sitting ready to do my analysis in that directory, and I didn't have to do anything. So It makes it very easy. Now you might say, well, how do I know what it's actually doing? There's debug and trace switches. So if you throw even debug on there, first of all, notice how much more stuff shows up on the screen. But if you were to collect prefetch and then manually run PECMD with that command, all of this stuff right here is what would end up showing up on your standard out. So you can still see that with debug when you're building your own modules, trust but verify. You want to make sure that it's actually doing what it's doing. Just turn on debug and you're going to see every single thing that the tools are doing. Now, if you want to get really crazy, you can go trace as well, but this is fully drinking from the fire hose, and it didn't take too long for that thing, but you have to be careful with that one because it'll if you do big collections, it might take a lot longer, especially with all my tools, because those flags are going to be honored in the other things as well, potentially. So just be aware of that depending on what you're doing. But it's that easy. I could run as many things as I want. I think it's called Easy Tools. I could run that. That's a compound module. And yeah, it's not quite that one. So let's see what it is. CD modules, CD compound. Easy parser. So if I run module easy parser, now it's going to run every single one of my command line tools. Now the tools are generally smart enough to know there's no work for them to do. Right? You didn't collect an MFT, I'm not going to run that. You didn't collect a $boot, I'm not going to run that. But otherwise, if I did the KAPE collection, the KAPE triage, and then the easy parser all in one, it's going to run all of my stuff against all of your output, and you're going to have tons of CSVs ready to go in like literally probably 60 to 90 seconds. And that's it. You don't really need to build anything else, at least to start. You might also always have to go back and grab something else based on subsequent investigation, but that is going to be enough to significantly move just about any case forward if you do your collection right.
So let's go back to the scenario you were describing earlier, where I've got this process that's running the KAPE utility to acquire from my 20 most critical systems every 15 minutes, go out to these servers and collect those. So now I've triaged those into this compressed file that you got locally. How much more difficult is it to change my source to be the H drive, to be that that compressed zip? Do I have to uncompress that? Do I have to?
Sure.
Can I point?
So let's say by default, the way I was doing this, and this is the way that I generally recommend that you do it, is to put your collection into a VHDX. Well, that VHDX is mountable. Now, the zip file becomes your original evidence. So we don't ever want to touch the zip file. So what I would do is, we want to go back 3 months at 12:30 on a Tuesday, find the corresponding collection, extract out a copy of the VHDX, double click it. It's going to give you a drive letter. Let's just say it's the L drive. Now, all you would have to do is
change the source. Yeah.
Go here and say L, but I'm not collecting again though, right? So all of those things go away. It's M source L. That would be your command line, because I want to process the files that live here. I've already collected them. I don't need to recollect them. And I want you to give me all of my work product here. So that would be, we need to go back in time, mount a thing, run it. I could always go back and post-process it. Now, could you script that and have it automatically extract out the zip and mount it? Sure. That would probably take somebody 10 minutes, but I generally am just going to extract out the VHDX somewhere, double click it, get my drive letter, and then do this. And then you would end up with this happening against all the stuff that you already have collected in there. From registry to event logs to file systems, whatever it is, you're going to end up dumping out into your CSVs from that point in time, which is why it's so nice to do it that way. Then when you're done, you just unmount the VHDX, you move on to the next one. Here is $J, and so you can see the name, the category, where does the file live, what is the mask? And so it's that simple. Now that's an alternate data stream. So that's why we have that syntax there, which is pretty common. That's how you're going to access them. But USN Journal has an alternate data stream named $J. We extract it out. So that's it. Now, the other cool thing about pretty much all the targets and modules If you scroll down, we typically have all kinds of documentation links in there. So if you want to know about, well, what is this? How could I use it? How do I read this? There's all kind of references and resources down there for you to follow up and get additional information on what exactly that means. So prefetch, same thing. Go here, get me this. That's it. Bunch more documentation. Now, link files and jump lists is a little bit more involved. I said link files and jump lists, but I also said you should have targets do very specific things. But link files and jump lists are so closely related, we just put them together. So here, this first one is going to include all of your recent link files as well as your jump list, because that's where they live underneath that folder. And we're just going to recursively give me everything. I'm not giving you a file mask or a file specification like star.link. I want everything in this folder and recursively. So you could go crazy and copy the entire user's app data folder if you want, which would be huge and probably way overkill, but you can. Now, another one that I'll bring in here as an example for people that are a little bit more capable with defining regular expressions. This is going to be significantly faster than having each of these extensions in a individual star.3GP, 3G2, 3GP, AMV. If we can define a regex that says star dot something or whatever your regular expression is, this is going to make a single pass through whatever your target is and literally find all those extensions and copy them out. So if you trade off a little bit more complexity for having to build a regular expression to define your file masks, you gain the benefit of the collection being even faster. And so the way that this works is this says C, this says C, Windows prefetch, etc. Well, sometimes people think, well, what if I'm collecting on the L drive? Well, do I need to go into these targets and change C to L for every single one? No. KAPE does all that. We use the nomenclature C:// whatever, because that's usually where these things are going to be that we want. But if, like, for example, when I pointed KAPE at H, at runtime, KAPE would go in here and change C: to H:. And it handles all that flip-flop. You don't have to do any of those things. So you've got all these various options. And then again, just as one last example here with a compound target, we talked about file system. You can see here that we're going, there's the $J one. Notice that these are just other TKAPE. The path is a TKAPE, and TKAPE is a target KAPE definition. So all of these files that I have open, TKAPE. So if I say something.tkape, KAPE goes, oh, I know what that is. That's another target. Go find $J and expand it. So it would go and read this one, and it would pull all that. And then it would go back and pull $log file, $MFT, etc. So you get the benefit of consistency, compound, basically roll up individual targets. These are all related to the file system. But again, if somebody's like, I only need to know if the USN journal is aware of this particular thing, well, I'm just going to pull this. I don't need to wait around for everything else. Now, modules, on the other hand, look slightly different. Let's just stick with the easy tools ones, since that's the ones I was doing. We did PECMD. We'll bring in two different ones. So here's PECMD. Now, notice it looks almost identical. There's a couple other little things here, like this category that determines what folder the results are going to end up in. And then this binary URL is where you can go get the tool. It's important to understand that only easy tools are included with KAPE. There's, I think, like 300 plus modules that you can use with KAPE. One, I would not be allowed to just distribute them all legally. Two, even if I could, I wouldn't, because if somebody's like, wow, these modules are awesome, I'm just going to run them all. And somebody, for some reason, decided to make an S-delete module because they just wanted to automate wiping their drives, and you just like YOLO and send it. Well, now you're going to be like, well, Eric, why'd you wipe my C drive? Well, I didn't, you did. But now, if I can come back here, and I can actually do this to give you an example. Let's do, I guess I could pick anything. I'll just do Density Scout. So notice it does its thing, but when it tries to run Density Scout, it's like, sorry, I could not find that executable in the appropriate place. It doesn't exist where I expect it to. Sorry. Now, that's because KAPE does not come with Density Scout. So if you wanted to go run that, the way that you would do, whether it's SRUM dump or whether it's Density Scout or any other executable that we don't include, as to kind of bring this example full circle, if I go into Density Scout, just like we saw before, there's where you could go get Density Scout, and you'd put it into the modules bin folder, and then you'd run it again and it would work. Now, again, if you're like, well, I don't like that command line, I want this to be 0.13, go ahead and change it. You could make your own. But another thing that a lot of people will do, it's not just executables. You could run PowerShell and have PowerShell run things and all that kind of stuff. So there's no real limits to what you can execute. Obviously, it doesn't make much sense to try and do a graphical tool unless it has some other way to be automated. But most of the time here, we're going to be pointing this stuff at command line tools. So literally any command line tool that you can come up with, you can automate, and you'll only have to do it once. We have volatility in there. We have Plazo in there. There's all kind of stuff. And not only do the existing targets and modules serve as examples for syntax and ways to optimize stuff, but we also have guides that will walk you through the entire process of making these targets and modules. So all this stuff is built in and included. So it gives you basically like a template. Now, almost always what I would do, find an existing module that's close to what you want, Control C, Control V, rename it, and then edit it around. The only other thing you need to really know when you're making your own is this ID. That must be unique across all the targets and modules. That is how KAPE makes sure that it only runs things once. It would make no sense for you to collect the same target 8 times, because 7 times they're just going to get overwritten. It makes no sense to run a command line tool against the same data more than once. So every time KAPE executes a target or a module, it keeps track of this GUID, and that's why they have to be unique. KAPE will not run. It will tell you, oh, you got a duplicate ID, and it will refuse to run if you have that in there. Now, how do you get a unique ID? KAPE has a GUID switch that will just dump 10 random GUIDs to the screen every time you run it. You also can go out and get them via websites or any other way you want. A lot of times I'll just cheat usually, and I'll go in here and say 41F. That's unique, and it's good enough. So on the rare cases that you ended up making a duplicate because you typed the same ones in there or whatever, KAPE will tell you, and off you go. It's also going to verify all this syntax. So for example, if you put a tab character in there, it would say, nope, that module has a tab. It's on line 42. Go fix it and try again. Now, the reason why it does all that validation up front, you would be upset if you spent 5 minutes doing a collection and you ran a bunch of tools and then you got a syntax error in a configuration file. So it does all that validation up front to make sure that when it actually starts doing stuff, it's not going to run into a problem down the line.
Let me ask you a question that just came to mind. If I go back to the syntax you were using earlier, you specify the target or the S target, and then you were able to add modules to the end of your targets. But when you wanted to just run the modules, you defined an M target. So by default, if you don't have an M target, is it going to use whatever the T destination was as the M target? Is that what it's doing?
That's exactly right. And now I don't know if you've ever seen that before, or you just were thinking how's it going to know? But yeah, that's exactly right. And that's exactly why it does it. If I define something like this, well, how at runtime, or how am I going to know what the machine name that you're running it is? And how am I going to know what the exact timestamp down to the second that you're going to use? So I can't say M source and hope that I get it right. Now, if it was this, you could certainly say M source is tdest, but that's kind of redundant. So when you leave off M source, KAPE is going to say M source is missing, make M source tdest. And since it's already expanded those variables, it's going to work every single time. So yeah, that's all handled as well. So those variables are going to be substituted before modules run. And so M source would get the appropriate, EZW and whatever the current timestamp is. Yeah, that's all transparent.
Okay.
And exactly why. Now, GKAPE, if you use GKAPE, is smart enough to force you into that selection process as well. So if you only do targets, it knows that mSource and mdest is required. Or if you only do modules, rather, it knows that mSource and mDestination is required. But if you're doing targets and modules, it will not make you put in an mSource. Now, notice I haven't done anything yet. Look at the command line down here. Nothing there. Now, also note that I have 289 targets and 381 modules. That's what exists right now. If I click sync, this is the part where you might not be able to see what's going to happen. This is going to execute KAPE. It's going to download all the newest targets and modules. And then you can see here, as soon as I exit, it's going to refresh. And now I have 302 targets and 385 modules. So people are constantly giving us new targets. We're constantly making our own. And you literally just have to click that button to automatically get all the changes. You don't have to go check or anything like that. Now, notice there's also an execute button down here, but can't click it because we haven't told it to do anything. So if I check use target options, notice that whole half unlocks and GKAPE has already started to build a valid command line. So up here, if I hover over that box, it's not showing it on the video, but that's going to bring up a tooltip. So target source, that would be -- T source. So here, if I said target source H, look at what it did down here. It just put that exact switch in for me, except I didn't have to type it. There's no way I could have messed it up because all I gave it was the H part. Same thing with target destination. Now this one should have an example already in it there. It does MRU, so it will remember that. If I pick this, notice that it filled in that. But I still can't execute this because I have not filled in one of these other red ones. So I can just find whatever I want, prefetch, and now notice that it does, in fact, allow me to execute it. Notice also that it's built me a full command line. So I can just copy this out. The GUI switch is press any key to exit. You would never use that if you're doing this programmatically, but I want the end user to be able to see the result. Otherwise, it would run and the window would go away and they'd be like, what happened? So that's all the GUI part does. If I was going to do this at scale, I can copy it or I can come down here and click this and I would have it. Now, if I want, again, you're not going to see the KAPE window pop up, but if I run that, it's just doing the collection. It's over. 0.9 seconds. I hit enter and I'm right back here. So it built me that. Now, if I unlock the module, notice that this half opens and it started to fill out some of the other details. Notice that module source, like we were just talking about, is not required. But if I disable this, it becomes required. So the GUI is smart in that it is going to make sure that you do everything it needs and you're not going to get like, oh, I don't know what that switch is, or you didn't provide this and all that. So it really does make it easy to use. So here, if I just said C:\temp M out, and then I go in here and say easy parser, notice that it built all that second half of the stuff for me that I did manually when we were doing it by hand. And then I can hit execute. It does it. Same exact KAPE window just popped up. It's running. It's doing all the things. And now it's done. I hit press any key to exit and I'm right back here. So you can do your containers. So we could just say demo. You could do that. You could set up transfers. All this stuff right from here is going to be, this isn't actually a, valid one, but you can see that if I did, it would put that in there for me and off it would go right to a SaaS URI in Azure land. So makes it super easy for us to go in here doing volume shadow copies. Just check the box and you get it. So this makes driving it super easy. And two, because when you hover over those boxes, a tooltip will come up that tells you what the command line switch is and what it does. Everything becomes easier for people to learn. This was really built at the request of Ovi Carroll, because he said, if you need to build a graphical front end. And I'm like, no, people could figure it out. And he's like, if you don't build a graphical front end, you're going to lose law enforcement. They're just not going to use it. I'm like, okay, but it's a great training tool. It's a great tool to figure stuff out. And then, of course, once you figure out what your command line is, you could just copy this out, go back to your PowerShell or your any enterprise tool that you have running on your endpoints, Carbon Black, Tanium, S1, anything that knows how to just run arbitrary commands, if you could just execute command line tools, you can use those to drive KAPE collections across your entire enterprise. We have examples of that and a bunch of PowerShell one-liners and everything else on the KAPE Docs website, which you can get to down here, or just literally Google KAPE Docs and it'll come up. So very, very easy to go in there. And if you're like, wow, what's with this? I don't want this this theme. Give me something darker. You could change the skin, right? So all my stuff has that in there as well. If we run that, notice that one of these, SFTP C. So now if I do cape.exe, that, and then it's config, I just named it config.scape. If I run this, and I'll do this in a second. So this particular one, I'll also do this switch just to give you an idea how and why. It just makes it easier. So if I run those two things, notice what it did. It said, oh, wait, I'm in SFTP mode, boop, 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 and it stood up all of the stuff listening on port 22 on every single IP that this particular computer has. And then it says, well, here's all the config that you gave me. So now, for example, it's sitting there, it's ready to listen. Now I'm going to keep this window up, but I'm going to open up another instance of KAPE, and then I'm going to use these parameters to actually to spawn something out. So sometimes it's, oh, there you go. That's what I want right there. So I'll just do the H drive again. But now if I go back to here, notice that it says, okay, if I want SFTP, I want to use Eric upload, download, or whatever. So I can just go, take that, drop it in here. Now I need an IP, and that's where one of these comes in. So I'll just keep it simple and do this one and go there. Now, when I run this, it's going to do the exact same thing before. Now, notice that it's also smart when it's using some of these options. What didn't I include on that command line? I did not zip up the output. So it's telling me, oh, nope, sorry. I can't, I'm not going to transfer this out. It did the collection. Oh, okay. So now I can just do VHDX test and it should behave like we want. So there it's connected to it. It wasn't able to delete the test file, but that's okay. That's just permission based on what I used. So it ran it, it did the collection, and then it transferred it out, right? And so over here on this side, which you could see in the background a little bit still, there it made the connection and all that. There's all the stuff. I just had to scroll down. So there's all the stuff that came in. Upload, download, that must have been a permission thing. So let's go this one. I'm going to use Mike All for our second example, and you'll see that it's still going to work for us, but you get an idea of what those permissions look like. See, now I didn't get the error message about deleting the file. So you get complete control over what you're allowed to do. It's obviously going to try to make sure that it can write. It would make no sense for you to give a read-only thing to this user, because what are you going to do? But whatever I just collected is now sitting out in that path right here, along with all the full logs and everything else. So you stand this up, you do your thing, you're done. All you have to do, you can see there, you hit Q, and now everything's good. You've got your full audit log of what went on the console. You've got your full audit log, which is pretty significant on the SFTP side as well. So right. It's included. You could obviously stand up your own, but this is so much easier to manage, especially if you're just going in and you're like, can you open up this port and all that other stuff? And it just, I found this to be a lot easier when you have to do this if you're not shoving it out to some, cloud-based resource.
Right. Or if you go in, you're doing incident response, you show up at the company's site, you don't want to have to worry about them creating domain accounts on shared file servers for them to be able to collect the artifacts on. Just to be able to stand this up on your own machine, which is not integrated into their environment, it's a really nice feature. And of course, it's all secured communications, so you don't have to worry about exposing the data. That's really nice.
Now, you could, if you wanted to, just to like here, there's nothing wrong. Like, it'll work with you going.
Yep.
Like you could
Oh,
totally do that.
share
But
something on your own
again,
machine. Yeah.
yeah, if that's your own box or you're in some
Yeah.
corporate infrastructure, who has permissions, like all that stuff, like you said, that's completely mitigated when I'm just shoving it directly to my particular endpoint. So, and it's going to be obviously depending on where you're responding into, that might be a lot faster for you to do collections than trying to push everything out over slow network connectivity, or maybe that's down because you had some kind of an incident, whatever. So what part of KAPE am I most proud of? I would think that the collection side of it is to me more useful. It's better than the module side, right? Yeah. At the end of the day, chaining all that stuff together and making the modules work and figuring out the variables and the way to make that flexible, that's cool. But that's not as heavy of a lift as doing the collection side of things and deduping. And I mean, fast. It'll iterate through with those targets in zero point 0.4 seconds. It knows about the 2,000 files that you need to find. Not to mention, shadow copy is done by accessing the raw disk. A lot of tools will use symbolic link methodology to get into volume shadow copies, which is fine unless you want special files. If you do symbolic link method, you don't get $MFT, USN journal. It becomes much more difficult. So accessing things as a raw disk opens up a lot more ability for us to be able to get to access to those underlying files. So the target collection side of things is definitely my favorite part of it. Shooting them out over the network and all that stuff, that works the same with targets and modules. But getting the data off of there fast and preserving it, that's by far, I think, my favorite piece of it. Yeah, for sure. When I'm a SANS instructor, so when I teach at events, a lot of times that's where people will come up to me, either at one of the like evening events, or if they're students in class, or I stick my head in somebody else's class, they'll um, say hi and hey, thanks for all your tools and thanks for this. Getting back to what the other half of what your question was, just at different events and stuff, we also teach this stuff. It's included in several different courses, and the feedback that I don't like, oh, that's great, we're teaching it in other places, but I mention that because then we get that real world feedback from people saying, this allows me to do so much more than I could do before. It really has helped move the ball forward. And that's all great, right? If that's part of your business and that's how you're putting food on the table. But the people out there on the front lines defending whatever their system is, right? It's important to them. This tool being able to help them wage that battle that we all know, having done this for any length of time, is just constant and raging. That's a win. Whether or not I hear about it directly, I know that for every one person that probably says something, there's 100 that use it, and it just never comes up. But it's always gratifying when you get feedback, like when people had a success story, or I was able to do this, or we couldn't have found that without that. So yeah, that stuff's always nice to hear. KAPE, like you mentioned, is free for just about everybody to use. The only exception to that is if you're going to charge somebody to use KAPE. Now, this is not legal advice. I'm not summarizing anything that a lawyer would say, but that, if you go read the EULA, if you want all the particulars. But the short version is, if you want to use KAPE for any purposes, it's completely free unless you are charging somebody to use it, right? If you're going to send somebody a bill to do incident response, and KAPE is a part of that, you need to buy a license from us, which is like, again, don't quote me on the exact price, but like $850 for unlimited seats, unlimited usage. So it's tied per like concurrent usage, but one user could buy a single seat of KAPE and you could run it on 100,000 endpoints. It doesn't matter. But
within a corporation, an employee within a corporation, since they're not sending a bill, since they're just doing it as part of their work, that's free?
Yep. So if you're using it to do your own internal whatever, it's going to be covered. If you're government, law enforcement, college, another nerd like me sitting in your basement and you want to get started on, like, all of that's free. You could just go to the Kroll website and sign up to download it. I guess that's the only requirement. It's not like a direct link you just get, but it's pretty low bar of entry. Now, there's no, oh, well, you need to get a license code and put in the license code, and that's going to do, none of that's in there. It's just, you get it, you use it, off it goes. So we certainly do have coverage of KAPE in a couple of SANS courses, like 4498 and I think 4508 and 4500 at least. Those are the ones that I know it comes up in.
Like your field data acquisition class.
Yeah,
right?
that's covered. 4498 would be digital acquisition and rapid triage. We have a huge section on all things KAPE in there. That this is kind of the tip of the spear. We learn how to do all the stuff that it can do for you automatically. We teach you how to do all those things, not so that, like, the last thing I want to do is teach you how to use a tool. See that command line? Just do that and change H to L. Well, what have I taught you except how to type something out? I can teach a non-technical person that. I would rather teach you what the tool's doing, how it's doing it, how to do things manually, how to run the command line tools manually, and then we automate up. So we learn from the ground level, what does things look like in the hex? What does an MFT actually look like? How does a link file actually work? And then we automate manual collection, manual running of programs. Then we automate a little more with various other triage tools, all the way up to doing it full blown. I don't have to do anything except, hey, KAPE, go here and get me this, and you're done. But when we teach it that way, we don't teach automation first, because that way we get a chance to show people in that crawl, walk, run style of progression how stuff works, so that they're equipped to write a good report, speak intelligently to their boss, have to testify in court, whatever that ends up looking like. It creates a much more firm foundation than, here's a couple command line examples. You don't really need to know, like, magic happens here. I want to avoid that as much as I can. It just doesn't do us any good in the long term. Thanks for having me on, and I appreciate not only the ability to talk about my software, of course, but the previous episodes. They're really interesting, again, especially from the historical context of the tools that have come out over the years and why they were written, and the people behind it. A lot of times, when things aren't the way that things today aren't the way that they used to be, and it used to be that your complete online persona was only ever a handle. So The Hobbit, right?
Right.
That name out there, that's a person somewhere. You have no idea who that is. In today's age with Zoom and all these other things, it's a lot less of that kind of, I don't know if mystique is the right word, but it's interesting to see the people's what they look like, what they talk, how they talk, what they're saying, and why their reasonings, like the episode about the war dialer and all those things. So all of those things are interesting, and it's something I think that, at least that I'm not aware of, preserving a lot of that knowledge is interesting, and it's useful to me. I find it fascinating, again, having grown up in that era where I saw that and remember all the magic and the wonder of what that looked like. And I clearly remember watching the back orifice episode with some of the Windows 95 stuff and some of the dialogues, and you're transported right back there, remembering insert the disk with the driver on it, and just like all those memories and things come flooding back to be able to go back and relive it. But so just thanks for doing that. As well.
I'm glad you're enjoying it. I have certainly appreciated the opportunity to meet some of the legends of the industry, and just have the opportunity to sit down and talk with them about the tools and their motivations and things like that. And that certainly includes you and all that you've done for the forensics community. So I appreciate it. Glad to call you a friend, and look forward to grabbing some dinner sometime at one of our upcoming SANS events.